Hi, hello, good evening everybody. This is Chinmay Joshi back with one more a very important topic for your CBSE Mathematics board. Yes, welcome to Diksha Vedantu revision program, and today we will deal with triangles. Yes. Okay, as you requested yesterday, sir, we want some proving problems, we want some solving problems. So I've come up with a very interesting proving problems today. I hope you are already there. Just give me a thumbs up if you notice this, right? So I'm back with the proving problems today. Triangles is one of the most important chapter, and this chapter carries around 6 to 7 marks. So this particular chapter carries around 6 to 7 marks and very important, and you might expect one MCQ questions, one short answer and one long answer from this. So around 3 plus 2 plus 1, around 6 to 7 marks will be allotted for this, right? Okay, so without any delay, let's start with today's session. Yes, give me a thumbs up if you are already here. Yes, welcome everybody. Yes, okay, let's go with the synopsis. Yes, so you have only two basic synopsis here, so two things you'll have to notice. So one thing is basically what is called BPT theorem, right? So there is something called BPT theorem, right? So what is BPT theorem? Anybody, can you please text me? Yes, what is BPT theorem? Sir, this is basic proportionality theorem. So this is one part in triangles. The second part that you can expect is similarity of triangles. So similarity of triangles. So these are the two major concepts that you will learn in this particular chapter, right? So BPT, what does the BPT says? Okay, consider a triangle. Yes, consider a triangle, say ABC. If suppose there is a point in between A and B, and there is a point say P and Q in between AB and BC, and if suppose this line BQ, if suppose this is parallel to BC, if one second, if PQ is parallel to BC, see if PQ is parallel to BC, then what you can say, these two triangles, that is triangle APQ is similar to, APQ is similar to, we usually write this, is similar to your ABC, triangle ABC. So this is your BPT theorem says. So converse of the BPT theorems, what does that say? Sir, converse of the BPT theorem says, if suppose these two are similar, these two triangles are similar, then this PQ is parallel to BC. This is the converse, right? So sir, what is the use of this? So why do we need BPT theorem? So obviously the BPT theorem is required in order to find the lengths of the particular value of the triangles or sides or angles. In that case we will be making use of BPT. Okay, so now there are few things you should know. So from BPT theorem, what are the results that are obtained? So what do you mean by similar? So similar means they are corresponding parts of the corresponding triangle, right? So they are basically equal, sir. I mean they are proportional. So in that case, see, for this AP divided by AB, or you can take AP by AB is equal to AQ by AC. See, you can take first two of this, next two of this, and the last two, that is PQ by BC. So this is what your theorem says. So there are so many results from this, we will discuss one after the other, and we also have the proof of this theorem. Much we will definitely get proof of this theorem for 3 marks for sure, and I will discuss the proof now. This is just a synopsis part as of now, right? So what do you mean by similarity, sir? Similarity means two triangles, you can take any two triangles, say ABC or PQR and YXZ. If suppose this side is same, and if suppose this side is same, and if you have this side is same, and if suppose this side is same, and one more side, say this and this, if you have this, then you can say these two are similar. Sir, how did you say? Sir, there are three criterions to mention two triangles to be similar. What do you mean by similar? Their corresponding sides and their corresponding angles are proportional. See, I have learned something called congruent. So what do you mean by congruent? Congruent means their corresponding sides and corresponding angles are equal, but in case of similarity they are proportional. Hope this is clear. So what are those criterions for similarity, sir? So first one is AA criterion. If suppose two angles, then if suppose two angles are equal in both the triangles, then we can say those two triangles are similar. The second case is SAS, that is if suppose there are two triangles with same two angles. If suppose if you have this angle and this angle are same, and the sides corresponding or the sides including this angle, this side and this side, if suppose they are same, then we can say according to SAS criterion these two are similar. See, for congruence you want AAA, SAS, ASA and SSS. So for this there are three. One is AA, SAS and SSS. So all the three sides if they are same, then clearly they are, yes, what do you say? Or all the sides are, if they are proportional also, then you can say these three triangles are, these two triangles are similar. Hope this is clear. So this is short thing about your BPT theorem and similarity theorem. Okay, let's take up the next part. Okay, so now let's prove. See, as I've mentioned, SAS similarity, BPT theorem, and the converse of BPT theorem and basic proportionality theorem is also called Thayer's theorem. So as I've mentioned, all these things are available for you. So you will have to make use of this digital thing to write the answers in such a way that you will get the full marks, right? Okay, so let's take up the next part. Okay, as I've mentioned, this is the proof for your BPT theorem. Sir, how do you prove BPT theorem? See, let's take the statement of BPT theorem. What does it says? If a line is drawn parallel to the one side of the triangle to intersect the other two sides in distinct points. What do you mean by this? So a triangle is taken, and if you draw a line that is parallel to another side, so and these two are basically two distinct points. The other two sides are divided in the same ratio. So what do you mean by this? These two sides, this side and this side, this side and this side. So other two sides are divided in the same ratio. So what does this say indirectly? Sir, from here we'll have to prove. What should we prove? To prove your AD by DB is equal to AE by EC. You are supposed to prove this. That's it. Very simple thing, but the proof is little bit out of the box. So how do you get this? Sir, I want AD. So in a way, if I can get the area of the triangle somewhere including this side, then I can make AD over here. So I want AD, DB, AE and EC, right? So let's consider, where is this AD present? Let me consider this triangle ADE. Consider triangle ADE. In triangle ADE, so what is the area of this triangle? Sir, area of triangle ADE is basically, sir, half into, what is base? Sir, base is AD, sir, into height. Sir, height is EL, sir. That's it. Okay, so similarly I also want AE. Yes, can I get AE? Yes, it's very clear, sir. For a triangle AE, that is ADE only, taking the area of ADE from taking the base as AE. So the same area of I'll take AED. So if you want, I can take it AED, so that from here the area would be, sir, this is again half into, what is base? See, instead of taking this as a base, I'll take this as a base now. So you have AE into, what is base? That is AE. What is height here? Sir, this is DM as of now, right? So now you've got AD, AE. Okay, now my job is to make sure that I'll prepare this DB and EC. How do you prepare DE? Sir, DE is somewhere here and EC is somewhere here. So EC is somewhere here. So my job is to bring that. So DB and EC should be brought into picture. How do you bring? Okay, so now if you can consider this triangle, I hope you can notice this color. I'll take a red color. I think you can see this is one triangle over here. Yes. So this is one triangle over here. And there is one more triangle. Let me mark it with a different color so that is visible to you. You can see two triangles here. So one of the results in your 9th standard says, if suppose one second. So if suppose the areas of the triangles are the same on the same base and between same parallel lines. See, they have the same base, these two triangles. See, I consider this triangle first and this triangle second. So you have two triangles with the same base and between same parallel lines. So between two same parallel lines. So whenever you have something like that, area of those things are same. In fact, they have said area of sir BDE or BDC is equal to area of EBD, right, or BED. Right. So from the theorem that you have learnt in the 9th standard, we will make use of that theorem and prove this. Okay, again let's take the area of this, sir. And also one more thing, for an obtuse angle triangle, for any obtuse angle triangle, remember the altitude or the height is measured or the perpendicular is taken outside the triangle, right? Okay, Nidhi Nayak says, sir, how is the height of the triangle AED? How is the height of the triangle BD? How is the height of the triangle? What did I take? Can you mention it properly? How is it DM? Okay, see, because this is the height, no? So consider this triangle. If you consider this triangle, let this be base, okay? Let this be base. So in that case, this will be height, no? So DM will be height, no? So this is base, this is height. So that is what I'm taking. So this is clear? Yes, okay. So clearly you have got it right. So whenever you have a triangle that is obtuse angle, so obtuse angle triangle, whenever you have, see, this is obtuse angle triangle, right? So this is obtuse angle triangle, you have one triangle over here and another one triangle over here. So these two triangles areas are same. So that is BDE is one triangle, the another triangle is DEC. So I'll take it as DEC. Okay, I'm sorry. So this is DEC. So from here you can get EC and DB. So BD is here, EC is here. So that is how I've chosen that. Right. So now what will you do, sir? As I've mentioned, if it is an obtuse angle triangle, its height. See, for this particular triangle, I'll take a different color now. So for this particular triangle with a black one, so observe only the black one as of now. For this particular triangle, the height is basically EL. The EL is the height, because this is obtuse angle triangle and its perpendicular come always outside the circle, I mean outside the triangle. So similarly for this triangle, if I take a different color, let me take a purple one. So for DEC, so this is the triangle as of now. For this triangle, the perpendicular is outside. So if you take the perpendicular for this, so then the perpendicular is somewhere here. Yes, somewhere here. Yes, for this perpendicular is DM. So always try to see if there is an obtuse angle triangle, then its perpendicular is always outside the triangle. So from here what you can consider, sir, from here area of your BDE. So area of BDE is basically half into what is base. Sir, from here base is, I can take it as DE or DB. This is base. Okay. So into height, sir, height I'll take it as EL. Right. So similarly area of I want a DEC. So area of DEC is half into what is base for this? See, I want EC. So this is, I'll take this as base, and height would be your DM. So this is your DM. So half into base. So this is base and this is height. So half into EC. So for this EC into what is height? Sir, height is taken as EL. I think the height for this is DM. I think I've taken it the other way, I guess. Yes, I hope I've taken it right. So in this sense, yes, I've taken DM, correct. So you, both the cases I can take it as DM, because both of them are basically the triangles that contains the same base as well as the parallel line making the same these triangles. So in that case you can consider the height to be both DM. So you can take this also DM, one with EL. So because we are taking AD by DB, so in that case DB, right? So I think this is EL, correct? So this is EL and this is DM. So why we are writing like this, sir? So because I want somehow AD by DB, see AD by DB, and I want AE by EC. So AE by EC. So and these two should cancel out. So you can accordingly plan it something like this, how to get these things, sir. So sometimes we might get confused. Don't worry, this is how you can think of, sir, AD. So first in case AD is a base and height is EL, and in the second case, sir, AE is the base, DM is the height. In the third case, sir, if I take BD as a base and its height is EL, this is the height because it takes always outside, and for this case, sir, EC is the base and its height is basically the DM, always it goes outside. So remember this. Okay, in that case, now we have got everything ready. Just divide this by this and this by this. So take this as equation 1, equation 2, equation 3 and equation 4. So divide 1 by 3 and 2 by 4. So from this you will end up with the final thing, AD divided by DB. See, that is cancelling these things, you will end up with AE by EC. Similarly, cancelling these things, EL, so you will end up with AD by DB. Hope this is clear. So just by dividing them you will end up with the final results. Hope this is clear. Yes, great. So these are few corollaries for the same thing. So you have AB by DB for this particular triangle, AB by DB is equal to AC by EC. So similarly, the next corollary is DB by AD. So DB by AD, DB by AD is equal to EC by AE. Similarly, you just have to take the corresponding parts of the triangle. Hope this is clear. The last corollary says AB by AD. So what is, sir, this is AB by AD is equal to AC by AE. These are all basically the corollaries for the same thing. Hope this is clear, Nidhi. Yes. Okay. Yes. Let's take up few problems now. Come on. Problem number 1. In the figure, PQ is parallel to MN. PQ is parallel to MN. They have given KP by PM. KP by PM to be equal to 4 by 13, correct? So now what is KQ if KM is given to be 20.4 centimeter? Okay, right? So the question is very simple now. You just have to take BPT theorem to solve this. Sir, KP by PM is proportional to, or their ratio is equal to, KP by PM should be equal to KQ by QN, right? KQ by QM. So, or I want KM and KQ, no? Okay, they have given KN, not KM, I'm sorry, this is KN. So, KN, the whole thing is given as of now. So, the KP and PM is given. So, from here I can find KP by PM is nothing but 4 by 13 as of now, and from here what else is given? Sir, KQ is asked and QN is not known. What we can do is, sir, now I cannot apply this result. I want something, see, since they have asked what is, since they have given the KN, you want to find KQ. So let's take KM now. So I can take KM by KP. So whichever that is given, MP is given, no? Okay, what we can do is, let's take this together. Okay, so your KP by PM is given, this by this is given. So what we will do is KP plus PM, or this Q1 is given, no? So in this case what we can do, Q1 can be added to KQ to get KN, right? So the whole thing they have given it to be 20.4. This whole thing is 20.4. So let's try to get it right as of now. Give me a second. 1 second. Okay. Yes. So now what we will do is, basically we'll start with taking this part. Sir, KP by PM is given to be 4 by 13. So now what we will do is, so Kn is also given. Sir, Kn is 20.4 centimeter. So this whole thing is around 20.4 centimeter and this ratio is 4 by 13. My job is to find what is KQ, right? KQ, this thing is unknown here, right? So, so from here KP by PM should be equal to KQ by QN. So this is KQ by QN is equal to same 4 by 13, correct? So now I don't know what is QN, that is a problem here. So in fact they should have given QN. Okay, so in that case Kn is given. Anyway, how can we solve this? Yes, Kn is given. So I'll have to break this Kn as KQ plus Qn. So in that case you can get the answer. Or let's try to see this. if this is 4 by 13, this is 4 by 13. So if you take one of the options over here and the Kn is known, so from here if you substitute it here, then what might be the answer? That is one way of looking into this question, right? So from here what you can observe is basically, see, if you start with taking this to be 4.5 or 4.8, see, if you take this as 4.8, this by this will be equal to this by this. How? Sir, you have 20.4, so total to be 20.4. Yes, the whole total to be 20.4. So let me take this Qn as 20.4 minus x. So what is x here? I'll take this as x. So now your job is to find what is x. So that is one way of getting the answer, right? So now what we will do, sir, Kp by Pm, if suppose that is a case, Kp by Pm is also equal to x by 20.4 minus x. Yes, so this is also equal to 4 by 13, right? So now 13x is equal to 20.4 into 4 minus 4x. Take this to the left side. So what happens? So this becomes 17x is equal to 20.4 into 4. So x should be equal to 20.4 into 4 by 17. So if you simplify this, you will end up with option A as an answer. Hope this is clear. See, whenever such things are not given, see, sometimes the whole thing is given, then you'll have to break it into x and 20 minus the whole minus x. So then you can find the answer. Yes, the answer is 4.8, sir. Very good, Nidhi. The answer is 4.8. That's correct. Hope the method that is solved here is clear for you. Yes. Let's take up the next question. In the given figure, DE is parallel to, this is parallel to BC, sir. Okay. Therefore, these two triangles should be similar. So clearly, since they are parallel, their sides are proportional, hence they are similar. So now what we will do, I want what is the value of EC. See, if you can see, this side by this side is equal to this side by this side. So now if you see the proportionality, 1.5 have been raised into 3. So into 2. So clearly what will you multiply? So clearly I will multiply this with the 2. So the final answer that you get is basically 2. So sometimes you can just observe the proportionality. So 1.5 divided by 3 should be equal to 1 by 2, right? So 1.5 is 1.5 by 3 should be equal to 1 by x. So x is what we are supposed to find. Find this ratio, that is 2 times. So therefore your x should be 2. Hope this is clear. Yes. Let's take up the next question. So next question says, in the given figure x, what is x? The question is, in the given figure, what is x? So this is x a, and this is 46 degree, and this is also 46 degree, and this is m, this is n, this is k, and this is l, and this is b, small b, and this is small c, right? So now you have these things given now. So they have asked what is the value of x, okay, in terms of ABC are the options, right? So how do you get this? Sir, we know that these two are basically parallels, and therefore they'll follow or they'll satisfy BPT theorem. So the angles are same, and these two angles, see, this is 90 degree for both of them. Two angles are same, therefore they are similar. Now what you can do, I want x, no? So sir, x by a should be equal to one more known term. So x by a should be equal to, I'll take c by b plus c. See, I'll take nk by mk. So nk by mk, because this is also equal to this, no, according to the corollary of BPT. So that is whole, that is km by kn is equal to x by a. So they are corresponding paths over there. So therefore x should be equal to, what is nk? Sir, nk is basically c, but this by a, this is basically b plus c, mk is, sir, b plus c. The only option that is having b plus c, there are two options having b plus c, but x should be equal to ac by b plus c, because this x a is taken to the left side, and the answer should be ac divided by b plus c. Hope this is clear. Yes, respond in the group chats, guys. Yes, okay, let's take up the next question. In the figure, DE is parallel to BC. They have given DE to be parallel to BC. Find the length of the side AD. I am supposed to find what is this length. What is this length? Given that AE and all these sides are given. So clearly what you can see, sir, this is 1.8, this is 5.4. So 18 into 3 times is basically 5.4. That is 18 3s are 54. Similarly, what should be multiplied with 3 so that the resultant is 7.2? That is how you can think of these questions. Very simple questions, right? So what 3s are 72. So let's check. 24 3s are 72, 20 20 20 60, 4 4 4 12. So clearly 2.4 is correct. See here, if you take 22.2 into 3, that is 6.6, wrong. 3.2 into 3, that is 9.6, that is again wrong. 3.4 will be 12 plus 1.2, that is 13.2. All of them are wrong. Okay, so Mahalakshmi said clear, sir. Well done, Mahalakshmi. Hope you are getting things here. Yes, great. So also, if you are liking these things, please share this video with your friends and hit the like button there itself. Yes. Okay, that's a free thing for you. Okay, let's take up the next question. Come on, answer this. So whenever you have MN parallel to BC and they have given AM is to MB. So this is, they have given is AM by MB. They have given this to be equal to 1 by 2 or 1:2. They have asked what is the area of AMN by area of ABC. Area of AMN by area of ABC. Always remember the areas will be always your any sides, corresponding sides whole square. That's it. So this will give you the final answer. Since you have AM is to MB to be 1:2, the final answer will be 1 by 4. Always remember this. So whenever the, is it 1? Okay, AM is to MB is given, no? Okay, I'm sorry. Okay, the final thing you are supposed to get it something like this. 1 second. So they have given MB, not AB. So that is why my job is to get what is AB first. So what is AB? Sir, AM by MB is given to be 1:2. So this AB will be equal to 3, no? So this is 1, this is 2, say. So AB will be 3. So or you can take 1x plus 2x. So since they have given the ratio, we will bother about the final thing. So clearly it is 1 by 3. Very good. Mahalakshmi has mentioned it is 1 by 3, sir. It is not 1 by 2. Very good, Mahalakshmi. So it is 1 by 2 is basically AM by MB. So I want AM by AB. AM by AB is 1 by 3. But I want the whole square of it since they have asked the area, right? So in that case, what we will do, I will take 1 by 9, sir. So therefore option B is correct. Okay, Mahalakshmi, have you answered it for this or the final answer? The final answer is 1 by 9 because AM by AB is basically 1 by 3, but I'll have to square it off, right? Hope this is clear, Mahalakshmi. Yes, let's take up the next question. Okay, in a right angle triangle ABC, right angled at B, it is right angled at B. Okay, so if P and Q are the points, so P and Q are the points on the sides of AB and BC respectively, then AQ square plus, see, AQ square plus CP square, AQ square plus CP square is equal to, see, if you can consider, try to see this as two right angle triangles. Okay, so let me consider this as two right angle triangle. This is one right angle triangle and one more is I'll take with a different color, the red one. So this is one more right angle triangle. Consider these two right angle triangles. This is one triangle and the one with this part, purple part, right? So that is APB and CPB, AQB and CPB, right? So one more triangle is ACB, right? They are all right angle triangles. Okay, great, Mahalakshmi. Not for the final answer, sir, but it is 1 by 3. Great. So basically I want AQ square. So how do you get AQ square? Sir, this is hypotenuse. Since it is right angle triangle, I can write AQ square as AB square plus BQ square. Okay, sir. Similarly, what is required? CP square. So let me take CP square. Where is CP? Sir, CP is here since it is hypotenuse of this right angle triangle. This is PB square plus CB square. Okay. Yes, sir. So now you got two things. Let's try to okay, and also your AB square can be written as AP plus BP whole square. Similarly, your PQ square, BQ square can be written as, see what can it this can be written as, try to see this. Okay, one second. See your CP square over here, CP square is basically written as, sir, this is CB square plus, see, using the Pythagoras theorem, I just have written this. I want CP square plus AC square. Add these things, but CB square and this BP square, see, try to see it, BP here, sir, BP square is equal to AB square. BP is this, that is equal to AB. Why? AB square, and see, I have written AB square here, BP square here, and BQ square. See, what is BP square plus BQ square? Try to see this. Okay, so the thing is, if you add these two things, sir, AQ square plus CP square, try to see this. So this is nothing but, sir, AB square plus AB square plus BC square. So I'll take that, see, from here and from here I'll take these things together, right? So next, what are the left things, sir? This is BQ square plus BP square. What is BQ? Sir, BQ is this, BQ plus BP. So this and this is taken over here. Sir, but what is AB square plus BC square? Sir, AB square plus BC square is nothing but AC square. So somewhere you can link this. Sir, this is AC square. So, and what else is left? Sir, where does this BQ comes? Okay, this BQ is here, and this PB, sir, PB is here. Now what will you do? BQ square plus PB square from here, BP square plus BQ square. So PB and BQ, if you take these two, the resultant is basically PQ square. So PQ, so you can take this as one more right angle triangle. This plus this will give you PQ square. So in that case, so what you can do, so you have PQ over here, one more right angle triangle can be formed between PQ and B, so that will give you PQ square. So that you can take it as, sir, PQ square. So therefore the final answer should be AQ square plus CP square is AC square plus PQ square. Hope this is clear, everybody. Yes, let's take up the next question. So these are few types of questions you can expect from MCQs. Now we will solve few short answer questions followed by long answer questions. Okay, so how can you expect short answer questions? That is for 2 marks. So this is one such question. As in case of yesterday, you think I think you have asked, sir, let's solve few proving problems, sir. Definitely I have come up with proving problems. Sir, how do you think about this during exam? Yes, so as Nidhi being asking, sir, how do you think? Yes, definitely it's a question. Sir, how do you think that as an exam? See, Nidhi, what you can do is you can look into the options, okay? See, all of the options are telling something like AC, AC square, AP, PQ square. So try to see observing things over here. If you start observing things, what you can see, AQ square plus CP square. Sir, I want AQ square, this square plus CP square. This is what is required. So try to write it in terms of Pythagoras theorem, and then what you can do is see the options, and I should get AC square somehow, all of that has AC. I should have PQ square somehow, all of them are basically containing PQ. So how do I get these? Then if you think of it, see, if you can clearly group these things out, see, I want AC. How do you get AC? Sir, this AC can be obtained by this triangle, sir, AB square plus BC square. This is how you can think. Similarly, I want one more to be PQ. PQ is not connected, so you should connect them. Sir, PQ if you want, PB square plus QP square. So this is how you can think of this in exam. Nidhi, is this clear? See, look into the option. Most of the answer will be told by your options only, right? Especially in your MCQs. Let's take up the next question. The first question says, in the figure, angle D is equal to angle E. AD by DB, they have already given AD by DB. So this thing AD by DB is equal to AE by EC. Prove that triangle BAC is an isosceles triangle. I need to prove this bigger triangle to be isosceles triangle. Yes, let me draw this properly once more. So this is a triangle consisting DE to be parallel to, this is DE to be parallel to BC, and this is A. So they have said angle D is equal to angle E, and their corresponding sides are proportional. So they have already told it follows BPT theorem, right? Okay, so now how do you solve this, or how do you prove this to be isosceles? In order to prove this to be isosceles, my job is to prove, sir, this two sides are equal. What are those? Sir, AB is equal to AC. If I can prove this, then my job is done, right? So how do you prove AB is equal to AC? Simple. Since they have given angle D is equal to angle E and also it satisfies BPT theorem. Converse, they are parallel. So since they are parallel, this side is equal, or this angle is equal to this angle, because adjacent sides or adjacent angles, and this side is equal to this side again. So you can also tell them corresponding angles. So this and this are corresponding, this are this corresponding. So therefore from here, from the data, we can say that angle D, angle B is equal to angle C. Why? Corresponding angles. You should write everything corresponding angles. So now you got two angles to be same. So always you have learned this in your previous classes. Whenever two angles of any triangles are same, their corresponding or their opposite sides are equal. This is a simple thing. So when two angles of a triangles are equal, then their opposite sides are equal. If suppose this is A, B, C over here, since they have mentioned B is equal to C, AB, the side opposite to C is AB. So from here, AB is equal to AC. So clearly we've got this to be isosceles triangle. Yes, so for this you should write a reason stating that opposite sides of equal angles of a triangle, equal angles of a triangle are equal. So this statement carries 1 mark. If you write this only, then you will get a mark. Hope this is clear. Yes, let's take up the next question. Okay, so in the figure, if the triangle A is 90 degree, so they have given angle A. So let me draw this once more. So you have this. So angle A is 90 degree given. Okay. Angle B is 90 degree given. Okay. OB is equal to, so this OB is equal to 4.5 centimeter given, and OA is equal to 6 centimeter given. Okay sir, and AP is equal to 4 centimeter. AP is equal to 4 centimeter given. Okay sir. So now find QB. So my job is to find what is this. Okay. So now clearly what will you do? Sir, let me consider this angle. See, if you can consider these two are vertically opposite angles, sir. These two angles are same, and angle A and angle B are both are right angle triangles, sir. So according to AA criterion, I can say these two triangles are similar. So how do you write these two triangles, sir? Compare A. So A should be corresponding to B. Okay, and your O should be for both, whatever that is left. So P over here and Q over here. So these two triangles are similar now. So you can write it something like this or something like this. So something like this. I think this is the one that is assigned for you guys. So these two triangles are similar. So now what will you do, sir? Since they are similar, they'll satisfy BPT theorem. So what you can tell, sir, AO by BO is equal to the next two, OP by OQ, and first and third, AP by BQ. So now whichever that is given, just try to mention it. Sir, AP is given, I'll take AP, and BQ is to be calculated, and AO is given, sir, this is 6, and BO is given, that is 4.5 is equal to, I'll skip this and I'll take this. So this is basically AP. Sir, AP is given to be 4 centimeter divided by, let me take this BQ as X. So now try to simplify. This is 3 times, this is 2 times, 2 times of 4.5 is 9. So 3x is equal to 9, then x is equal to 3. So if you simplify, 4.5 into 2 is 9, 9 by 3 will be 3. So the distance or the length of this is basically 3 centimeter. So if you can observe these things here, so you had 6 by 4 is equal to 3 by 4.5. They are one and the same. So this is how you can verify this. Yes sir, QB is equal to 3 centimeter. Mahalakshmi says yes sir. She gives a thumbs up, and Nidhi Nayak says QB is equal to 3. Well done Nidhi, super. So let's take up the next question now. This was asked in CBSE 2012. So what does this question says? Sir, in the given figure, G is the midpoint of the side PQ of triangle PQR. So they have said G is midpoint of the triangle PQR of one side, and they have told GH is parallel to QR. So they have said sir, GH is parallel to QR. Prove that H is the midpoint. Prove that H is the midpoint. My job is to prove what is this? H to be midpoint of the triangle PQR, of the side PR. So this is the question. Okay. So now what will you do? How to solve this question basically is, since they have mentioned this to be, these two are parallel, so definitely they'll satisfy BPT theorem. So from here what you can say, sir, PG by GQ is equal to PH by HR, right? So one thing what we can notice here is, sir, GH and since they are parallel also, but also they have mentioned G as a midpoint. If G is midpoint, then PG and PQ aren't the same. So PG and GQ aren't the same. So clearly this side should be equal to this side because this is a midpoint. So in this case I can cancel them. So PG and GQ are one and the same. So you will end up with 1 as an answer. So 1 is equal to PH by HR. So from that case I can get, sir, HR is equal to PH, sir. Very simple. Since they have mentioned G to be midpoint, now I have proved that HR is equal to PH. So HR is equal to PH. So clearly what does this say? So therefore your H is the midpoint of PR. H is midpoint of PR. Hope this is clear. Yes, hit a like button if you get this. Yes, let's take up the next question. In the figure, triangle ABC, the points D and E are on the sides of CA, CB respectively, such that DE is parallel to AB. Clearly this looks like a scene of, yes, this looks like a scene of BPT theorem. They have said AD to be equal to, AD is 2x given, and DC is equal to x plus 3. This is given x plus 3. This is given to be x plus 3. I'll write it here, x plus 3. And one second. Okay. So this is x plus 3. This part they have given this to be x plus 3. The next thing that they have given is BE. BE to be 2x minus 1, and the another part CE is equal to x. So this is given now. So my job is to find what is x. So clearly this triangle, these two triangles are similar using BPT theorem. So their corresponding sides are proportional. From here what you can say, sir, CD divided by DA is equal to CE divided by EB, right? So from here what you can get, so you can write CD to be equal to x plus 3 divided by 2x is equal to x divided by 2x minus 1. Solve for x, you will get the final answer, right? Yes. So if you take this, becomes x plus 3 into x minus 2x minus 1 is equal to 2x square. So if you take this, sir, this becomes 2x square minus x plus 6x minus 3 is equal to 2x square. Okay. So 2x square get cancelled. You will be left with 5x is equal to, so this is 5x is equal to 3. So from here you will end up with 5x is equal to 3 and x is equal to 3 by 5. Hope this is clear. So now you have got x to be equal to 3 by 5. So that is how you can get the answer. So whenever such things are given, just try to take their sides to be proportional, corresponding sides to be proportional. That will bring you the answer. Let's take up the next part. Yes. In the given figure, these two triangles are given. Find the values of y and z. Similar type of problem. This was asked in CBSE 2019. So let's see how to tackle this question. Right. Sir, since these two triangles, this angle is equal to this angle, so 90 degree, and one more angle they have given it to be 30 degree. So clearly by AA criterion, that is angle criterion, you can say these two triangles are similar. So they follow what BPT theorem. So in that case, how do you write, sir? QP by BA is equal to QR by BC is equal to PR by AC. Very simple question again. So now how do you solve this? Sir, QP is 3, BA is Z, this is 6 by 8. This should be equal to PR is y by 4 root 3. Very simple, you can get the values of z clearly. What is z? Sir, if you take 6z is equal to 24, z is equal to 6 by 24, that is 4. We've got z to be 24. And what is y from here? Sir, 24 root 3 is equal to 8y, right? So 8 1 times, 8 3 times. Sir, y is equal to 3 root 3. Simple thing. So now they've asked what is the value of y plus z. So y plus z is basically, sir, y is basically 3 root 3 and z is basically 4. So therefore your final thing is basically, sir, there is x is equal to 4. In the last question x is 4. How come x equal to 4, Nidhi? So I've got 5x is equal to 3 and x is equal to 3 by 5. Hope this is clear. If you have any ambiguity or if you have any confusion, just put me text saying, sir, this is my problem, so and so I can rectify that, right? So let's take up the next question. This is one more interesting question, not so direct question. So this looks a little bit of difficult. No problem Nidhi. So z is equal to 4, then it's fine. Okay, so in the given figure, ABCD is a trapezium. They have given it to be trapezium in which this AB is parallel to CD. So this is C. This last part over here is basically C. One second. So whenever you see the last part over here, one second. So the last part over here is C. Okay, whatever you see here is basically C, right? So now prove that AE by ED is equal to BF by EC. Sir, how do we prove this? How do we prove this without taking any triangles? Sir, there are no triangles, only trapezium is visible, sir. How do you prove this? Okay, so here you need to make a small construction. I'll take a line over here. So this, let the point of intersection be some O. Okay, so now you have these two triangles, this one triangle, this is the second triangle, and this is the third triangle, and this is the fourth triangle. So you have 4 triangles as of now, right? So now my job is to find AE by ED. Now you've got this to be triangle. AE by ED is equal to BF by E. I'll have to get BF by EC. So the last point that you see here is, so if you want I can draw it once more here. So this is something like this. This is the trapezium. One second. So this is E, this is E, this is A, this is B, this is F, this is C, and this is D. So the calculation that or the construction that I've made is basically taking some midpoint or taking 2 triangles as of now. You got 1, 2, 3, 4 triangles as of now, right? So my job is to prove this by this is equal to this by this. So what we will do is we start with taking these two. Clearly this angle is equal to this angle and they both have same common angle. See, angle A for both of them is same. So angle criterion, I can say these two triangles are similar. From here what I can say, sir, AE by ED is equal to, look for the common parts for both, sir, AO by OC. AO by OC, right? So this is the first part. This by this is equal to this by this. So this is from triangle 1 and triangle 2. So if you take triangle 3 and triangle 4, see, AE by ED is already ready. I also want BF by FC. So what is BF by FC for these two triangles? Clearly this angle is same for both and corresponding triangles. So this angle and this angle are same for them. Again, AA criterion, you can say these two triangles are similar. Once you say these two triangles are similar, you can apply BPT, that is BF by FC is equal to AO. See, I'm taking this part and this part is equal to this part and this part. So AO by OC. So now everything is ready, right? So both of them are basically AO by OC. So compare these two. This is equation 1, this is equation 2. So if you equate the right hand sides of the equation 1 and 2, you will end up with, sir, this is AE by ED is equal to BF by FC. Again a very simple question. See, but the key to answer this question lies in construction. Always remember, the construction over here brings the triangles, or else the trapezium will not give you the results as in case of triangles, but you'll have to construct triangles in that and see whether you can apply BPD theorem, right? So mostly you'll have to think in this way to get the answers for these type of questions. Okay, so probably the last question for the day. So this question says, in the given figure BC, this BC is parallel to PQ. So BC is parallel to PQ. Sir, BC is parallel to PQ given. Okay, so they've given what is BC, what is PQ, and what is BA, and what is PA. All these things are given. My job is to find what is CA. So my job is to find what is this, and AQ, this. So these two sides are to be calculated now, right? Okay, I'll give you 10 seconds guys. I want you to think about it and tell me an answer, right? So how do you consider? So sir, this angle and this angle are vertically opposite. Clearly those two are equal. What else can you say? Since they are they are parallel, that is also mentioned here. So since they are parallel, you can directly apply BPT theorem because they are parallel. These two triangles, what are those two triangles? So you have APQ. APQ should be equal to, or not equal to, similar to, triangle APQ is similar to, see, APQ. So then you will take, see, this PQ and BC should share the same place. So BC should be on the right. So your angle, whatever A is common for the both. So triangle APQ is similar to triangle ABC. Now your job is very simple. Just apply the logic. Sir, we know that AP by AB is equal to PQ by BC is equal to AQ by AC. Hope this is clear. Okay. So now, sir, AP is given. Okay, that is 2.8. Whichever they are given, just try to write them. Sir, is AB given? That is also given, 6.5. Okay. What are we supposed to find? AQ and AC itself. So what else is given? Your BC is given and PQ is given. So BC and PQ both are given. So BC is here, PQ is here. So AP is given and AB is also given. Okay, so let's take any one of this. You see, this becomes some decimal wise. So let's avoid this. Let's take PQ and BC. No, so PQ is basically 4 centimeters, sir. This is 4 centimeter, and BC is 8 centimeter. So that is already given. So the ratio is basically 1/2. AQ by AC. What is AQ? Sir, AQ that is not known by AC. So that is what we are supposed to find. So their ratio should be half as well. That should be 2/8 by 6.5. How do you find AQ from this? Sir, from this what you can do is basically from this triangle AB by AQ is equal to BC by QP and AC by AP. That is what I have written it here, AB by AP by AB, PQ by BC, AQ by AC. So in a reverse order, that doesn't matter actually, you can write it in any order. So now the next part is 6.5 by AQ. So here, so in the 6.5 by AQ, I think you can mismatch these things. So what you can do is I can take AQ as one of this side and AB as one of the sides. So in that case what you can do is basically 6.5 by AQ can be written as 8/4 into AC by AP. This is what you can take. So from here I can get AQ directly, that is half is equal to 6.5 by AQ. 6.5 by AQ. So that will give you AQ to be equal to 6.5 into 2, that is 13. So from here you can get not 1/2, I think this is 2/1, I'm sorry, 2/1. So in that case what happens? Sir, 2AQ is equal to 6.5 or AQ is equal to 6.5 by 2, that is 3.25, I'm sorry. So this is your AQ. So similarly, once you get AQ, you can also take AC by AP. I also know AC is asked and AP is given to be 2.8. So from here what you can say? Sir, AC by AP should be equal to, AC by AP should be equal to, sir, error in the question. Okay, what is the error in the question, Harsh? Okay, let's see. See, AC by AP is known to be say 8 by 4. So AP is known. So let me take it as 2.5 directly. So this is 2 by 1. So this is 2.4. So AC by 2.4. 2.4 or 2.8? This is 2.8 is equal to 2 by 1. So from here what you will have, AC is equal to 4. This is 2.8 into 2, that is 5.6 centimeter. So what is the error, Harsh? Can you let me know what is the error in the question? The question is very simple. You try to bring this something like this. You can imagine this to be something like this. So bring this to this is ABC and PQ will be somewhere here. If you bring this somewhere here, this is 4 centimeter, this is 8 centimeter. So where will you place P, where will you place Q? That actually matters here. So your Q should be placed here, your P should be placed here. So in that sense you can get this whole triangle part. So whatever you can see over here, if you want I can write it once more so that you will not get confused or something. Okay, so the part of this question says so AQ by AB is given, okay, AB is given, okay, AQ by AB is equal to AP by AC, which is equal to QP by BC. That's it. So now I think you can solve this. See, if you take this here, this will come to the left, so this Q will come to the left and P will come to the right. So this is the error in the question. Hope this is clear. Yes, yes, Harsh laughs out loud. Okay, so in that case you hope the question is clear and you can get the answer clearly. So we've got AC to be equal to 5.6 centimeter and AQ to be equal to 3.25 centimeter. Hope this is clear, everybody. So whatever that is taught today is clear, I hope. So so if you have any doubts you can pose it in the next class and you can come up with few interesting questions also. I'll try to solve it here itself. Yes, with that note, I wish you a very happy Sankranti to all of you. Enjoy this weekend and also don't forget to hit the smash the like button, and I'll see you in the next class. Till then, take care. Bye. Love you all.